Hi guys, welcome back. We are continuing our discussion on how to integrate double integrals over non-rectangular regions. I want to just friendly remind you guys that you're doing something like this when your bounds for one of your functions is going to be something that's not constants. It's actually going to be functions. So we're looking at the fact that since this is in terms of y, this is going to be y equals sine of x, and then y equals cosine of x. So over here in brown, we've done the cosine graph, and then in pink, we've done the sine graph. And then you can also notice that that's going to be our top and our lower bound with respect to y. And then our left and right hand bounds are going to be from pi over 4, which I've drawn already right here, which is the intersection of sine and cosine. And then also at 5 pi over 4, which is actually going to bound in this region. So you've actually done stuff very similar to this back in calculus A, B, and BC, where we are finding the area under the region. In this case, we're going to be finding the volume of it at the fact that this is going to be 1. So there's actually no function here. There could be a ton of functions. We've done this before. So all we're going to do here is integrate 1. But before we do that, we're going to go ahead and start by rewriting our outer bounds because we'll take care of this little guy later. So we're going to be 5 pi over 4 and then pi over 4. And so we're going to integrate 1. So since we're doing it with respect to y, the integration of 1 is just going to be y. And we're going to evaluate this from sine of x in our top bound. And then our bottom bound is going to be cosine of x from, and then also our dx. There's a little bit of lag on my computer, so I apologize now for that. Okay, so we're going to integrate pi over 4 to 5 pi over 4. So we're just going to recopy this down. And we're going to do the fundamental theorem of calculus, where we're going to plug in sine of x for y. So we get sine of x for y, and then minus the cosine of x dx. Okay? And so we just did a quick substitution where we see y, we plug in the top function, sine of x, plug in y for cosine of x, and we get this simple function that we see right here. Okay, so before I continue on, one of the things that I absolutely love that we use all the time is our mnemonic device for the signs for cosine and sine when we're taking derivative integration. So remember, when we're integrating sine and cosine, we will be very, very careful about this. So SCS, where 3 and 4 are both negative. Going down is derivatives and going up is integration. So it's just always nice to remember that tool. So when we are integrating positive sine, we actually come back to negative cosine. So we're going to go ahead and write negative cosine of x. And then when we're integrating negative cosine, we actually go back up because when we're increasing, because we're integrating, we get negative sine. And then we're going to evaluate this from pi over 4 to 5 pi over 4. And again, I am sorry, guys, about the lag of this computer. Okay, so what's left to do? You guys know this. Everywhere you see an x, we're going to plug in a pi over 4 initially. So we have negative cosine of 5 pi over 4. If it let me write it, minus sine of 5 pi over 4. And I'm going to tell you guys right now, I am not liking that color. It's a little too light for me. So let's just go ahead and change it up right now. Now we're going to go ahead and plug in pi over 4 everywhere we see an x. So we can do cosine of pi over 4. Ugh. All right, minus sine of pi over 4. All right, there we go. And then we're just going to start evaluating, right? So remembering that cosine of pi over 4 is negative square root of 2 over 2, but we have a negative in front of it, so it's just going to become positive square root of 2 over 2. Sine, negative sine of, sine of 5 pi over 4 is also negative pi over 2, but the negative of that is also going to be the positive, because it's in quadrant 3, so the opposite of that will keep them both positive. So there's our first term. And then cosine of pi over 4. Oh, you know what? I actually forgot to put here is the negative, right? I forgot this little guy right here, right there. So I'm glad I saw that. So negative cosine of pi over 4. My apologies, guys. So we're going to do the opposite of cosine of pi over 4, which is going to be negative square root of 2 over 2. And then we're going to do minus again. Sine of pi over 4 is the square root of 2 over 2. So we have square root of 2 plus square root of 2 over 2 is the square root of 2. Minus, this is a negative square root of 2. So it's going to become plus a positive square root of 2. And we get 2 square root of 2 as our final answer for this problem. All right, so I think we finally got there. It took a little bit of time. Again, I apologize, guys, for the lag of my computer today, but there you go for the problem. So a lot of this you've done before. It's just knowing what we're actually doing it about. So hope this video was helpful. I will see you guys again when we start talking about region 1 integrations, where we do non-rectangular regions. So have a good one, and I will see you guys in the next video.